So, our topic for today is modern information technologies for industry applications. Uh, my name is Alex Lifanov. I will switch to presentation mode from my side. Uh, so, I have some people are coming in more. Okay. What is with our chat? Regarding the names, there is no control of the presence as it is, but at the end we will have a small quiz, and in it you'll write your name once more again. So there is no issue if you're some letters, some numbers, or just guessed or something. So don't worry, it is not a problem. So, once more again, my name is Alexander Lifanov. I'm working now for Siemens company, and all my work life is connected to the industry. So I'm sharing my thoughts not only from my current working experience, but also from my previous. I was graduated from Moscow Institute of Radio Engineering, Electronics and Automation, which was once in old times a part of Moscow Energy Institute. So we are a kind of alumni. Then I spent almost 12 years in the chocolate industry. To be exact, it is loyalty to quality factory. It is still working, so you can get its production in shops. After that, I was working for Advantech company, that is Taiwanese-based company. Most known projects are Moscow subway. I mean the control checkpoints, which are controlling tickets, and Platon system, which is making which is checking for payment for heavy cars on our roads. And now, since year 18, I'm working for Siemens for Department of Digital Industries. So I'm connected directly to the manufacturing of various things. What will we talk about today? There are some maybe rumors that modern factory is quite an ancient. There are lots of mechanical works, etc. But I want to show you that is not fully true. That there are a lot of modern information technologies which are needed right now at the workshop on the manufacturing sites. So you will not get behind the progress if you are getting acquainted now with modern information technologies, because there are places where you can apply them in manufacturing, not only in pure IT. Some topics are listed. There are a bit of more of them. We are spared with 2 hours of time by our broadcasting system, but I hope we'll finish in 45 minutes to 1 hour with the lecture itself. After that, I suppose it will be okay for us to spend 15 minutes for some quiz. I will explain everything just right before it. And after that, I will let you to ask me any questions, not only connected to the lecture, but maybe to the Siemens, to the manufacturing, to some other things. Let's start. What is happening with modern industry today? Uh, we as Siemens are not directly connected to so-called B2C, I mean business to customer market, which we know personally, but B2B market or business to business, it is also following the same things, sanitary shops, stores, manufacturing, etc. You all know that what you want to get if you want to purchase something. First, you want to get the thing as fast as possible. You do not want to wait for manufacturer, even if the thing is customized in some way. For example, one person wants to buy a purple car, another wants to buy a black car, uh, but you want to get it as fast as possible. So customization of manufacturing is one of really modern and painful questions. Another thing you also may notice that the innovations are coming faster and faster, and all of them are needed to be implemented in real manufacturing as fast as possible, because it is a real advantage of each manufacturer. If you implement new thing in a ordinary production, you can sell it, you can get more money, you can go further. So the company who is making manufacturing more modern, that company is gaining more money. But besides this, uh, one more question is the quality of manufacturing. You know that the term Chinese manufacturer is usually connected to the lots of problems, but and both Chinese and not Chinese manufacturers are fighting with mistakes, with low quality, with design problems. So there are now some procedures which can help to manufacturers to improve their production before the manufacturing has started exactly. That are, let's say, external influence to manufacturing sites, but there are some internal factors which should be needed to be mentioned. For example, you may know that the transistor price, the calculation power is decreasing because of new lithography processes are being invented. So you can see the almost straight line going lower and lower. But at the same time, the metals and the plastics are not going down at the same rate. Uh, some things, for example, copper, which is making all the wires, um they are have the same price as last century. Even sometimes they are going higher. That means that the manufacturing machines and the production itself is not going down at the same rate in price. I mean, that means that every manufacturer needs to care for their equipment because. Every manufacturer wants to his equipment to work as longer as possible. But at the same time, you cannot stop your machine for any maintenance every day, because it is pure loss, and every manufacturer wants their equipment to work as long as possible. So the expense control is very critical now in all measurements. I mean, both work time and energy efficiency and loading efficiency, etc. Even sometimes now there is a reason to rent some equipment than to purchase it, because it may be cheaper in terms of expense per every item. You all know the same story even for us, because you can see, for example, car sharing cars at our streets, and it is sometimes in some situations cheaper to rent a car, to take a car from a street to ride to some place, or even to bring some goods from a shop to your home, than to have your own car. And the same thing is happening at the manufacturing sites. All these factors are leading to the uh, two more concepts, which are called Internet of Things and Industry 4.0 in the application to manufacturing. And in next several slides, we will talk about them. What is this, and what is needed for? But before that, I want to mention one more thing. Uh, some years ago, there were, let's say, two worlds which were very slightly connected to each other. I mean, information technology, IT world, and operation technology. As IT world, you can mention, for example, Dell company, IBM company, some Russian manufacturers like Kraftway, like Aquarius, etc., which are manufacturing the computers which are needed in the server room in ordinary offices, but they are not usually used in the workshops. At the same time, there were some OT companies like Siemens, like Allen Bradley, like Rockwell, like Schneider, etc., etc., etc. They were mostly dealing with manufacturing. It was totally separate equipment, totally separate concepts, different priorities, but because of the factors which I have mentioned before, these worlds are more deeply diving into each other. They are now connected, and sometimes it is quite hard to distinguish where is an IT and where is an OT. So our lecture today is dedicated to mostly to the IT technologies which are now present at the workshop, which are used in real manufacturing. One more thing I want to highlight before we dive into our story more deeply. Um, these worlds, IT and OT, are connected. They are diving into each other. They are fusing, but they have different priorities at their being. For example, for OT, for manufacturing, the top priority is availability of equipment and availability of control of the equipment. For example, if something is happening to some plastics or oil or gas manufacturing, it is needed to go further with manufacturing than to stop it immediately, even in case of some danger, because the immediate stop may be even worse than slight and controllable stopping of the manufacturing. So the first priority, once more again, for OT is availability. After that goes transparency, because uh, every manufacturing, it is all about the quality and quantity. So the management of manufacturing site every time wants to see what is happening inside the manufacturing itself in order to control it. And only after that goes security. It is needed to protect the manufacturing systems from any external influence, but the physical security in terms of keeping the control of the equipment is more needed for OT applications. For IT, there are other priorities. If something happens, for example, to bank system, first think that bank IT will do is to shut down the communications. Nobody cares what is going with the current transactions, with the fact you cannot get your money from ATM at some shop or pay for goods in a shop. But if there is a threat to bank IT systems, they will stop everything immediately. Because the first priority for Office IT is security. Security of data, security of money, and of course it is explainable. And after that, the second priority is user experience. Every user should be comfortable to use the software, to use some system, to use some item. Of course, you can see it with your cell phones. For example, you can take an Apple iPhone, which is some kind of ideal for user experience. It was designed around the user experience, and it is very handy to use it. For manufacturing equipment, it is not the top priority about the comfortability of operator. Operator may stand the whole shift, but the manufacturing should go. And after that, not even in each case goes the transparency. So I want to highlight one more time, there are different priorities for these two worlds. Let's go further. I will try to keep some kind of interaction to you during the lecture, so you can unmute yourself, you can say, and while we start talking about the Internet of Things, I will show you two pictures. One picture is opened. It is about the inauguration of Pope of Rome. The lower picture, it was shot it about the same phase of this procedure, but the lowest picture is quite different from upper one. You can see the number of year in which it was shot. Can anybody guess what is the difference between upper and lower picture? Any guess?
I guess the
Maybe
number of people.
No.
I guess lots of phones. Phones with camera.
Correct. Why? Can anybody guess what has changed during these 8 years? Why there are many cell phones? Because year 2005, I cannot say that there were small number of phones in the pockets. But why everybody is standing with the screen light? What are they doing? What has changed? I have passed a clue to you.
I think people want to save memories, and it's one of the reasons.
Yes and no, because before, even 100 years ago, a person can take a film camera or a VHS camera and make the same. But they are not using VHS cameras. There are no VHS cameras. They are making movies with cell phones.
Because it's more comfortable.
Partly yes. Okay. Nobody shoots for himself. Everybody wants to show his experience to the others. So it is not the video itself. It may be even streaming. So the difference between these 2 years is a change of generation for cellular communication speed. The upper photo was made during the last years of second generation communications, and it was quite slow. The speed was not enough to make video streaming. And the year 2013 was the first year when LTE protocol was implemented in real cell phones, and you can see it is around 40 times in performance, which allowed to not only film but also to stream out the video stream, to show to others what is happening in there. So all these things are happening because of network changes, and the network is everywhere in almost almost every wild place of our country. You can take your phone from a pocket, and you will have okay, not LTE, but some communications you will have. So you can share your picture, your emotions from almost every part of our world. We see that not only the communication is slipping into every hole, into every piece of equipment, but also the number of connected things is increasing. Of course, you know that in some time ago, everybody had maybe one computer in the family or even on the floor, but after that, every person purchased a cell phone. After that, a cell phone and a tablet. After that, cell phone and tablet and maybe a smartwatch. So for the current date, the number of connected things, smart objects, which are capable of interchanging data, is around 6 things per every person of the Earth. Of course, you understand that somebody has nothing and somebody has much more, but for today, it is evaluated by a known Cisco company. It is around 50 billion of smart objects in the world. And of course, each of these item is communicating to each other. They are exchanging data. They are producing their data. And all this information should be communicated by some way. When I'm on talking about the Internet of Things and the connected things, some older people say that this conception is not new because the telemechanics or remote control or telecontrol, this concept is over 50 years old, and even in old times there were means of exchanging data between some remote objects. But we should know that mostly the previous generation of such systems included one-to-one communication. But as you may see, the number of systems which want to communicate to each other, it is increasing, but the data is the same. So the number of links is increasing in an enormous way. And so what happened? People invented the ways of exchanging data, which requires a lower number of communication. It simplifies and makes quite an easy the process of exchanging data between smart objects, because they are also communicating to each other. About the language they are talking, you can see a kind of survey which was made some time ago by foundation, Eclipse Foundation, which is a company being developing software about what communication protocols are mostly used for connecting smart things between each other. The first position is HTTP, which we use for ordinary internet connection, and of course, things can exchange data in some kind of text way. But the second protocol is so-called Mqtt. Um, so we will talk a little bit about this protocol. It was developed quite a long ago in year 99, but in year 14 it became standard. It was not more a proprietary protocol, and for now this protocol is implemented in many devices. For example, smart switches, some kind of home controllers, etc., etc., etc. What are the characteristics of this protocol? I will not push you to remember all the things, but at least you should remember the principle. This protocol is very compact. It is asynchronous, which means that the message sent from one party to another do not require immediate answer. So that means it can work over bad communications, for example, in field over modem communication, or where is some radio noise, etc. Messages are quite short, so it is not dedicated for some video streaming or some extensive data exchange, but for some data telemetry or sending commands, etc. So it produces quite low traffic. The protocol itself is quite simple, so it fits for small smart devices like wall switch, for example. And it supports by itself the protection of communications by means of encryption, the key exchange, etc. We will not take this topic right now. But the main thing is about MQTT protocol. It differs from what was used before. For example, all industrial communication protocols were usually request-response protocols. That means that, for example, controller is asking some smart device, what is your state? And the device should respond, my state is on, for example, or my temperature is 31 degree. And after that, when controller wants to get information one more time, controller asks it one more time. But MQTT is designed in another way. It is called publish and subscribe principle. That means, for example, when sensor measures some temperature around it, for example, a temperature in the room or in the street, it actively, without any requests, pushes it or publishes to so-called MQTT broker, to some intermediate point which is known in advance. If some party which wants to know what is happening with the temperature, it makes one time, sends one packet called subscribe packet, and after that, when broker receive the measurement, it sends it out to the parties which have subscribed to this information. That first, that radically lowers the amount of communications, because temperature sensor do not need to remember which party has requested this data. It just measures and sends, nothing more. And all the orchestrating of the system is relying on the broker. And when, for example, mobile phones wants to switch off, it makes unsubscribe and broker stops to send out the data. So this protocol is for now assumed as a backbone of Internet of Things. It is kind of lingua franca, a universal language of smart things. So we see that there are a lot of smart objects in the world, and they need to exchange their data. What is happening with all this data? Modern factory has a very big number of various sensors. This is an average data of one factory dealing with some consumer goods manufacturing. I don't know, maybe paper towels or some napkins or something like that. But GE, General Electric Company, says that in average it produces more than 150 samples per second. You can calculate that every sample may be 32 bits or 64 bits with some not used data, some check codes, but that makes over 4 trillion samples per year. It is a huge amount of data which is needed to be processed, to be evaluated, to be stored somewhere, to be transported, and this whole thing, it produces an ocean, a full ocean of data. So during the rest of my lecture, I will use this metaphor with all other things. But you can imagine that all this data cannot be processed manually, and even it is not processed by automated systems in full scale. Some investigation companies say that only 12% of all this measured data is really used. All this data, all other data, it is either not needed, some redundant, some trivial data, etc. But it is only one. It is only 1/4, and all other 65% is a data which can be used, but it is not used really. The reasons are quite various. Some data cannot be transported from the measurement point to the place where is it needed. Some data needs to be pre-processed. Some data is quite complex to be extracted, and it needed some computational power. But the price of data that is not processed can be quite high. Do anybody know what is the place on the photo? Of course, you can.
Siena Sushinskaya, I guess.
Correct. Yes. And what is the date on the screen? The date is connected to this hydropower plant.
The day of the natural disaster, right?
Yet, it was a disaster, but it was not fully nature, or it was not at all a natural disaster. And I will dedicate some slides to explain what was happened, because the producing of electricity was stopped for more than 5 years at that site, and it was the most powerful hydropower plant in Russia, to be exactly. Cannot say that it was the most powerful hydropower plant in the world, but for Russia it was for sure. At the date, the hydropower plant was working inside an automated control algorithm, because you know that the consumption of electric energy in the country, in the region, it is not constant, but for now we almost do not have any technology to store it. That means that hydropower and every power plant needs to be controlled in terms of produced power. So there are quite complex systems which control the power output. Of course, they were oscillating in some way, because it was morning. When all the situation started to happen, it was around 8 a.m. It was the beginning of so-called morning peak, when everybody wakes up and starts to make his breakfast, to wash, to have shower, etc. But this generator has had quite a complex work characteristics. There was a danger zone in which the usage was not recommended, and of course the control algorithm has known about that, but it could not stand in it. So there was an oscillation when the work point has passing this danger zone back and forth, and that caused the vibration of working wheel of this generator. But look, vibration is not an unknown thing to this to our times, to the mechanics, to the designers. But anyhow, this vibration was rising, and it led to fixture destruction, which was holding the top cover of generator. You can imagine that hydropower plant generator is a kind of wheel which is laying on the side, and its axis is vertical. So lower bearing is deep inside the concrete construction, and the top bearing of this wheel, which is holding the axis, it is installed in the cover. This cover is fixed by these big bolts, which is holding all the construction together, but due to vibration it was destroyed. The vibration is not a new thing, and it can be measured. And there was some data extracted from the remains of control system. And you can see that the day of disaster was 17th of August. And even 2 months before, the average value of vibration of this generator passed over the alarm zone, and the maximum vibration passed even before, in May. What was happening? Why wasn't it stopped? Here is a citation from an investigation documents. They are public. You can read it by yourself. But here is a key point: that the vibration control system was not connected to the control system of the station, and it was not properly checked by the eyes, because every day it was showing the normal digits. So station personnel didn't pay any attention to the numbers which were on the screen. So when the vibrations started to increase, nobody stopped the generation of power for this generator. It can be done within less than 1 hour, and this disaster can be prevented, but that happened. So you can see that the data that was measured, it is not equal to information which can be used for control, for making some decisions. Because data without some knowledge, some context, some meaning behind it is useless for the control, for all the processing. How can we get the information from the data? We need to process it. One more kind of question. On the screen, there is a quite an infamous thing. It was one of United States supercomputers called Cray 2. It was manufactured during 10 years, since year 82 to year 92. It is not quite long ago. And it had a peak performance of slightly less than 2 gigaflops. Gigaflop is 1 million floating point operations per second. Try to guess what is the thing which has the same performance, calculation performance, I mean, which we can get now in our pocket, in our bag, at our home. Any guess?
Smartphone, maybe.
Quite close. It is an iPad. It is not a modern iPad. So you can imagine that we have times of calculation performance that has raised, and it is much more compact. It can fit in your small bag. And it can make the calculations at the same performance. So what can we do? For example, we have a milling machine, steel mill, which has its own control system, but we need to diagnose it to make some decision if it is performing okay, or something is happening with it, maybe some degradation of characteristics. So we need to make some calculation. So there is known concept which is called cloud computing, when you have somewhere at some place in some server room a big PC which is processing the data. So you are getting local measurements, you are just sending it out, it is processed at some other place, and then it is shown is it okay or is it not okay. But when you are dealing with some rotating equipment, the faster you are measuring, that is better, because you can get more thin details, more fine details from the characteristics of equipment. Because calculation power became more compact, there was offered one more concept called edge computing. Edge it is called because the calculation is moved from the center of network, from some core to the edge of network, and the things has changed a little bit. The processing of data, for example, the processing of high-speed vibration, it is made local on site, and only alarm data, or maybe once a day some specific characteristics are sent out. What doesn't mean for the control system and for the network? It lowers 1000 times the number of data which needed to be sent out. It is good in following ways. First, because you can process the data, you are getting more file details, as I said. Another thing, it is local system, and if some alarm situation is going out, it can be signaled for local person immediately without needed to turn over some remote server. Some other factors. There are algorithms, there are things which are not a part of the control system itself. For example, vibration measurement, as you can imagine, it is not really a part of a milling control, because milling control needs to produce some items and it needs to control the movement, but not the diagnosis. And during the time, there appear more and more added functionality, which management wants to get inside the control systems, but it is not good because it can affect the process of manufacturing. So it is more wise to put one more item beside the standard control system, not inside, because it is not affecting some working system. And third, for example, imagine you are the manufacturer of some milling machines and you are selling it throughout the whole country. If you get some update or some new function, and all milling machines are under the warranty, you should buy a ticket to your service person, and you should send it to install all the updates to all the machines. It is not cheap enough to make in the modern times. But if you have a connection to outer systems, you can just send it like we are getting updates for our cell phones, and it fixes some problems or gets some new functions. So that is one more profit for the users of such a system. What is inside of this system? The proposed solution is to have some marketplace like Google Play or Apple Store. You can have local storage just to cache the data, and you have some control items which are installed in real equipment, which are getting the application, which is making some useful things. For example, processes the vibration or measures the energy consumption or something like that. But you can imagine that the functionality is the same, but the equipment on the lower level is quite different. What to do? Siemens uses so-called Docker infrastructure for all the things. Maybe some of you have dealt with so-called virtual machines. What does it allow? It allows, if you have the same hardware, to run quite a various software over it. It isolates the functionality from one to each other because you can run several virtual machines in parallel, but it is not handy because you should have several operating systems at the same time. There is a modern concept called containerized applications or Docker applications, which are using the same operating core, the same hardware, but they are isolating from each other, and each of container has own file system. Of course, they can exchange data by network means, but they are isolated. But at the same time, Docker applications are quite lean in hardware use because they do not need to run the whole operating system for each other. For this infrastructure, there are lots of applications already developed, and sometimes you do not even need to develop a new application. You just take already ready things, for example, a database or some visualization part, and you are just sticking it together like a Lego. For example, I will show you what Siemens does with this infrastructure. There is a famous factory at which our Siemens PLCs are produced. It is the city of Amberg in Germany. And this machine on the screen is cutting the printed circuit boards from the bigger board. So there is a process of milling, and of course the process of milling makes a lot of dust. This dust gets into bearing, into motors, and at some point in the time it causes a jam. So the PCB cutting machine stops, and before you repair it, it produces nothing. It is obvious. So one of the things which is needed is to predict the stopping. The idea was to measure the current of the motor because the jamming of the spindle, it is not a one moment process. It is rising from the time to time, and as we have seen in the previous example of a hydropower plant, it can be diagnosed by machine. It's quite hard to do by eyes or by hand, but it can be predicted by machine when the milling machine will stop. Uh, this allows to analyze the vibration data or consumption data on site, right on the machine, but stream the measured things to other machines, so they are like teaching each other what to wait to predict the stopping of machine. It allowed the manufacturing factory to predict in 2 days in advance the stopping of this kind of machine. Let's go further. One more concept which is needed to be explained is digital twin. That means everybody needs to learn how to work in advance before you really dive into some deep water. The same is with manufacturing. Of course, we can start making the thing from the very beginning, produce something, get the errors, get back, etc., etc., etc. But the modern concept allows to make some so-called digital twin. It is a digital image, digital model, which can be tested inside the computer before you really manufacture each item. And when you design your machine, you can even make the digital twin of the manufacturing line, and you can get the weak point of your manufacturing even before you put the first brick when building a plant. We will show you it on the one example which I have got from Norway, from my colleagues in Norway. This is an example of press machine, hydraulic press, which is making metal details. And they wanted to optimize it, to lower the consumption. The designers of the machine did not start working on the metal from the very beginning, but they made the hydraulic scheme and run it into simulation software. That allowed them to get the weak point of the machine from the very beginning, and they got they made some optimization during the design, but at the same time they got some kind of ideal state of the machine. That is the next step. When they implemented the real machine, it allowed them to apply the ideal characteristics in the form of an advisor to the machine maintenance personnel, because they can part by part have a real state, the real performance, for example, of hydraulic pump, and the ideal. So it is a real help in diagnosis because there is no need for some old guy who knows this machine from the very beginning and which can diagnose it by just hearing or looking, etc. Now it can be done in analytic way. Let's go further. Of course, all of you, I suppose, have some smartphones, and there are some voice assistants, smart assistants inside it, so you can ask them to do something. For example, to get the weather forecast, or to turn on radio, or to note or to set an alarm clock, etc. But the same thing, of course, can be applied into the manufacturing, and it is quite modern, but it is not a dream, because I have seen first machines which are using these techniques. For example, some maintenance person can have his own phone and connect to machine and ask machine to help him. For example, to diagnose it, as we have seen before, or to move to some maintenance position, or to ask machine to get the documentation how to do any process. It is quite simple from the point of usage, but it is quite complex inside it. And I'd like also to tell you about the things which are living inside such a system. Of course, the translation of speech to text, it is not known. It is maybe 20 years old technology. And the chatbot, it is not also big things. You can see in the internet some programmable chatbots you can make yourself, for example, Alisa, etc. But behind the chatbot should get some knowledge of what is happening inside the machine. And this is a real core of the system, not the text to voice or voice to text or some question and answer. How to represent the knowledge which is behind the data? It is usually shown in some in so-called knowledge graph. And system is making inside the concern so-called industrial knowledge graph, which is describing modern tools, modern generators, modern equipment, and it allows to use this knowledge for maintenance, for example. What is contained inside the knowledge graph? It is not two variable data. It is more or less static data, and it shows the relationship between the objects. For example, there is a turbine. It is a kind of SGT 800, and it has some parts. And some person detected that there is some problem with the blades of this turbine, and it has a corrosion. That means if this real item has some problem that makes all the rest of the same turbines of the same situation or wear time, that should be checked for the same. This graph allows to make some decisions and to make some conclusions because of input facts. And this it is quite simple from the first point, but it really helps in implementing the kind of decision systems. Next thing I want to explain to you is blockchain. Of course, you have 1,000 times heard of it. You have, I suppose, heard of it because of cryptocurrency, but it is not the only application of this technology. What is a blockchain by itself? It is some kind of system which allows to implement trust between exchanging parties, but with it is without some central point of exchange data. Having central point, it is not every time good, because it is a weak point. If something happens with this central database or central registry, all the data has gone. Also, there is a problem with the trust, For example, you cannot make sure that nobody else is altering your own data. For example, you are writing that you are putting your money into the bank, but somebody writes off that money and you do not see it. So this is a problem of trust. The distributed technology, so-called distributed ledger, it allows for every party of the system to see what is happening inside. And blockchain technology, it is called because of its internal design. Each change of the state of the system, it is written in blocks, and every block has a header. This header contains so-called hash. You can think of this number of this digit as a checksum, which protects the data inside the block, so it cannot be altered. And every next block, it has a reference to the previous block hash. That means that you cannot alter something in the middle, something that already happened. That protects all the data. Another characteristic of the system that every block can be finalized when every party of the system agrees to it, at least more than 1/2 of all the parties inside it. That is called consensus. For example, everybody, or at least the majority, should agree that Alice has $3 and Bob is allowed to write off this $3. Um, it is good because the system works the system work is based on the previous state. So the previous block cannot be altered, but every party should agree to it, and it is a matter of time, not only computer power. Also, if some party can hold a majority in the system, more than 51%, this party can alter to themselves the decision making. So we are stepping back to the previous situation. New generation of blockchain technologies is called dagchain. It is directly a cyclic graph. It is shown like this on the picture. How does it differ from the previous situation? Every other change of the system state, it is not based on the whole picture, but it is based on the just 1, 2, 3 last blocks. But if these previous blocks are assumed by every party as trusted, that means that the new block is also assumed as trusted. It allows the system to perform much faster. The system has more robustness because nobody can affect once more again to the system, because for example, if this block is altered, there is another way and the system will stop here because this data will not match to itself. Where is blockchain is used in industry, because it is not widely spread information even for me. One obvious application is the usage for controlling of supply chain. For example, some farmer is making chicken, is growing chicken, and it registers that he sells this chicken to some factory. That means that he has really grown this chicken. It is not some contrafact. It is not a plastic or something. It is not bought somewhere. So all the parties are knowing where is the origin of this chicken. When producer makes some food of it, it also marks that from this exact chicken there are items produced, this, and this, and all this change of the system is also has written in registry. You can see that similar system is now implemented for tires, for some kind of food. In Russia, it is not obligatory for most of goods to be registered in this way, but over the border, for example, in Taiwan, the farmer production, it is obligatory to register their items, so every consumer and user can check the whole chain when it was produced, that the data of manufacturing was not tampered in the shop, etc., etc., etc. So it brings more trust to the system. And this example is taken from aviation fueling. The system is quite complex because it involves a number of parties. It is an air company, it is airport, it is finance service, it is fuel manufacturers. So each party should trust to each other and know for what they are paying or what they are moving. So this is another example of some called smart contracts, when parties are exchanging data to each other in a trusted and confirmed way, but companies are different, so there is no basis of trust between them. The last big topic for our lecture is cybersecurity, because every ocean has own predators. Maybe the consumer market, it is not feeling it in full scale, but here are some statistics from Benon Kaspersky company. So you can see that the number of malware or some aggressive pieces of software is increasing times per day. For the present date, the number I have heard is around 360 samples, new samples every day. Of course, all this flow of attacks is not dedicated to only privates or to corporates, but also there are more known and less known attacks. For example, of course, you have heard about so-called Duku attack to Iran uranium enrichment plant. Less known thing, when ThyssenKrupp have lost one of their steel manufacturing because their steel melting plant was shut down from the power, so it cooled and became a brick. And another story, maybe you have heard several years ago, is a Ukrainian power plant for several regions was shut down with a directed attack. So it is not public information sometimes, but it is happening each day. It is a fact. The first when this matter first arrived, it was offered so-called concept of air gap, when there should be a real disconnection from manufacturing systems to the places from which the attack may go, for example, from office systems or from internet. But in fact, it is not possible to be implemented in modern sites. As you can see, there is a CPU inside many things, and networks are wireless, and it is quite hard to cut it down. And some support systems should be every time connected to the internet, so there are lots of opportunities for attacker to get inside the system. So air gap concept doesn't work anymore. What is offered right now? Main idea is to make the cost of attack to be more than the cost of inflicted damage. In that case, the attack will be stopped because it will not reach its target in the most cases. How can we make cost of attack higher? The concept offered by Siemens and some other parties is so-called defense in depth. That means that all the system should be covered by several layers of protection covering each other. System should be split into some cells which are more or less independent from each other, and data exchange between them is controlled. But besides that, it is not only a kind of maybe hardware or software protection. The implementation of cybersecurity for modern control systems also includes some organizational measures when not all person allowed to work the system, to connect to the system, what it should be done when the attack is detected, it's so on and so on. So for now, modern cybersecurity, it is not about the hardware or some connection or some parameterization, but it is also about the organization. Okay, that was the last slide of my lecture. For now, I'm offering you to pass through a little quiz. There are 10 questions. Here is a link on the screen. I'm announcing you the the rules of competition. When you enter the site, you'll be asked for your nickname, your first and last names. You can register with some social network, or you can write down it manually. You can put any nickname, it will be shown during the competition, but for the first and last names, please state it in real, because the report will go to Dean's office, to your institute, as a confirmation that you have listened to this lecture and you have remembered at least part of it. I tried to make my questions not too complex, but please know that some of questions do not have only the one correct answer, but so look for ticks which appear on the screen. So 10 questions, 25 seconds for answering, 5 seconds for showing of correct answer. I am now launching the start screen. You will see the same screen at you. How many people we have? I'm looking at 20, including me and Roxana, so I'm expecting 18% to join at best. If you need, I can show you the link one more time, or you can open myquiz.ru. Here is the game code. I see 9 persons. If anybody has some problem, let me know. No more competitors. Okay, 12. 13, good. Also, I'd like you to remember that it is not only needed to get the correct answer within the time, but fastest answerers will get some bonus in score, so it will influence the final result. $14. Should we wait for anybody else? Okay, I'm making countdown from 10 and then I will launch. 10, 9, 8, 7, 6, 5, 4, 3, 15%. Good. 2, 1. Let's go. And the last question goes. And our winner is PAV. So you see your results. I'd like to say thank you to everybody who attended this quiz. Some final words for this meeting. If you want to get any more information, here are some links where I am attending. I will put the recording of this meeting in several days at my YouTube channel. So I want to thank you, everybody, for participating. If somebody wants to ask me any questions, I'm ready to answer. And if you want to ask it later, here are my contacts, my corporate contacts on the screen. So thank you very much for your attending.
Thanks for lecture. Goodbye.
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 Thank you very much.
Excuse me, may I ask you one
No,
question?
yes, of course.
Well, at first I should start with that my specialty is strongly connected both with IT and OT. And in my university, during all 3 years of studying, I was learning only that subjects which were strongly connected either with OT, either with IT. So I would like to answer you which subjects or terms I should acquaint with to become a better specialist than an average.
Look, when you come to real job, the winner point is between. So you will become best specialist if you know both sides. Of course, I understand that our modern education system is not intended for making the specialists which are wide educated than more narrow. But anyway, I'd like you to offer to try to get an IT background and then to try to applicate it in manufacturing companies. Because from one side, it will make you a background of knowing how to do the things. For example, to write modern applications. But from other side, at your first job place, you will get the story where to applicate your knowledge and your power. So it is in your hands, and I'm not sure that modern institute can give you this kind of experience. I know that Siemens has opened labs in several institutes, but also maybe a good offer for you is to join some practice in companies like Siemens Russia. You can check our website jobs.siemens.com, and there are regularly posted some vacancies for the people which have no experience. That can be one more opportunity for you to applicate an IT knowledge for manufacturing, for OT. From my experience, very few persons are transferred in another way from manufacturing to IT stories, because it is the IT, from my point of view, requires some special way of thinking, let's say, because when you write a program, you need to strictly divide your task to make step by step to make everything systematically, and even to me it helped me in even in manufacturing matters. So my answer is like this: continue to dedicate yourself in programming, in various fields of programming, in math, for example, for simulating matters, for analytics matters, but then applicate your power for manufacturing sites, for manufacturing companies.
Well, all right. That's it was pretty convenient answer, unless you didn't get my point. Like you didn't get it strictly. So what I've meant was I'm afraid of that situation in which I will have some skills both with IT and OT, but taking into attention the specific way of our of learning in our universities, I'm afraid that I would not have any special skills which can provide me with experience to connect OT side and IT side. And this skill would be, how to explain,
not needed.
quite useful in the real on the real in the industrial company.
Don't be afraid of this, because you can select your job place for your real skills, because of course you cannot know everything. You will definitely have strong points and weak points, and knowing your strong points, you can select the job place. For example, if you are skilled in mathematics, for example, you can go to the company which is dedicated for prediction analytics or for some simulation models. In other way, if you are strong in programming, ordinary programming, I mean like C, like JavaScript, etc., your knowledge can be applied for programming of control systems, because modern SCADA systems which are controlling manufacturing sites, it quite frequently uses web technologies, even that. If you are acquainted with, for example, parallel computing or something like that, or neural networks, there are lots of applications for artificial vision, or maybe some detection of data from analog values, from sound, from vibration, from current. So don't be afraid, because the manufacturing is quite a wide field for everybody to fit in.
Thanks. And would you mind to send us the link for this lecture? Because I would like to revise some material later.
Not a problem. You can see my email, because I do not know where to put it in some common points. So write me a notice, and I will answer with the slides and with the recording. Of course, not a problem.
All right. Thank you.
Any other questions?
Yes, I have a question. As far as I got it, you mentioned at the start of the lecture that you were developing the Platon system. Yes.
Yes, I was connected to it in some way.
And the question is not about the topic of the lecture. What's your opinion about this system?
Do you mean the intention of the system usage or its internal architecture? Because
Both.
okay.
Both.
I'm not sure that is really needed to use this system for payment control or some enforcement of limitations, but it is good for analytics, because after the first maybe half of a year of usage of it, the Rosavtodor got very interesting information about the cargo traffic for regional roads. As far as I know, they were really surprised with their findings. So if putting aside the financial story or some law enforcement or some kind of state control, let's say, it is quite good for statistics and analytics. And from inside, it is a very interesting distributed system. Maybe one of the first publicly connected widely distributed systems, because what was developed before, for example, region energy control or maybe some oil piping from Siberia to Europe, that they were working with a limited number of the data users, and they were inside some companies. But Platon system, maybe it was the first which was connected with a very big number of even of unqualified users which are running transportation companies with drivers, etc. So it was an interesting experience from the usage point of view. And also, of course, you should know that big number of equipment is installed in bare field. For example, there are several tens points on the road, for example, from Vologda to Arkhangelsk, and it is not the very best climatic situation. So it was a challenge to make it reliable enough and to make it working with the low amount of maintenance as possible, because for example, 500 kilometers from Vologda, that means 1000 kilometers from Moscow, you cannot just rise and run there for if something is broken. You should make many things remotely.
Thanks, but I got your point about statistics data, but I had trouble with internet connection, and I missed. What's your opinion in from the political economical point of view?
Look, I'm not happy with the money flows in our country. Let me be straight. But there is not too much thing that we can make in legal ways, let's say. Of course, if I am asked in the way of election, if in the way of some questionnaire, I'm answering my opinion. But so I'm doing what I can do from my position, not infringing with the law, let's say. I'm not happy that this system is used for some final limitation and for finance control or pushing payments to transportation companies, but it is a tool. The hammer is also a tool. It can be used for killing somebody, and hammer can be used for building a home. So that is the tool is not responsible for how it used. It can be used in various ways. So it is quite a separate story with Platon and its usage. That's why I was asking my first question. I'm not happy, and I'm doing what can I do.
So it wasn't planned at first to take money from from working people, and it was and this idea appeared after.
Look, I'm not too deep inside Rosavtador's to answer you for sure, but maybe that could be. Cannot answer you for sure.
Okay, thanks. And thank you for the lecture.
Not a problem. Any other questions?
Yeah, Alexander, I would mind to ask you one more question. Well, first of all, I should start with that I am quite interested in logical controller programming. I was programming your controller as well, Siemens Series 300, I remember. And usually I was used this kind of controller to provide the connection between this controller and pneumatic system or hydraulic system. So when you were describing the hydraulic press system designed in Norway, I've marked that that kind of scheme is kind of familiar to me. So I would like to ask you, are there any other programs or are there any other kind of industrial facilities which can be controlled with your controller and which are described with some programming interface like first fluid sim, which I know, and I don't know, and unfortunately I don't know any other
If I get your question correctly, look, the simulation software, it is not a direct tool to program something or to make a working cycle, let's say. This simulation software is a tool to simulate the process that is controlled from external. This is like a complementing part to each other. For example, we are using the tools like Fluid Sim to check the PLC program, because PLC program can be simulated and physical processes can be simulated, and it is used quite widely. The same story is with the mechanical processes, because the combination of real PLC and mechanical simulation, or virtual PLC and mechanical simulation, it allows to even to check for emergency situations control, to check if the PLC is handling it correctly. For example, one of my colleagues just finished a project at pipe manufacturing factory, and they used the simulation to improve the PLC program, because after some modifications, there were some disaster situation when the pipe of large diameter over the 1 meter ran off the tracks and damaged the part of the building. From the simulation point of view, it is not a tool itself to develop a control system, but it is a kind of complementing tool which helps to develop such a system. And from the programming point of view, it is almost any controller, even not Siemens, can be used for such a simulation, because Siemens has means to connect hardware to simulation software. There is a connection board, so even third-party controllers can be working with simulated processes which are simulated inside some system. Because what you draw in the software, it is not an electronics, it is hydraulics, and you are controlling it with some PLC. So this software is running the flows of liquid, its characteristics, because it can be not water, it can be oil, it can be compressible or not compressible. So characteristics may vary in the time, and for example, so this kind of situation, this kind of software is used for simulating hot water, which is converting into steam, which has totally different characteristics. For example, to simulate the heat exchanger, which is boiling, and the point where water goes to steam is not known, the exact place. It is used for calculation. So the tools are separate, but they are used together.
All right, so you mean that a combination of simulation programs and programming logical controller is more about describing the physical processes either than the way to develop your programming logical controller programming skills.
Yes, correct. Yes,
Yeah,
correct. That
right?
is because, for example, you have some factory and you are preparing your PLC, but you know the process is dangerous. I suppose you will not test your PLC software for the first time on real manufacturing because it is it is dangerous for you. It is dangerous for manufacturing itself. So the simulation software is clearing this kind of risk, and it allows you to, for example, save and repeat again as many times as you need to improve your software.
So I should focus on learning the programming languages of PLC more than trying to build some physical system, some pneumatic or hydraulic system,
Look,
right?
it depends on your plans because from my position, for example, I'm not, of course, I have studied physics, I have passed appropriate exams, but I'm not enough professional to simulate, for example, a complex heat exchanger. So if I need to prepare this kind of system, I need to find some technologist or some heat engineer to properly simulate this kind of software. From the other point of view, manufacturing sites and design bureaus usually have this kind of people which know what is happening inside their equipment from technological point of view, but they do not have enough skilled programmers. So these persons are usually used together, and if somebody hires the person which knows both professions, it is of course an advantage.
All right, I got you. Thanks.
Any other questions? Okay, guys, I was happy to talk to you. I want to wish you a good luck in your education and finding your way in this life. I will share my slides and the recording of this lecture on the network, so you can ask me any question if you want. So goodbye to everybody.